Hi everyone, I'm Gayan Abaynayake, ESR2 from Cardiff University. In this presentation, I'm going to summarize my work on DC collection systems for offshore wind power plants from the perspective of reliability, considering the component level to the system level. This is the outline of the presentation. First, I'll present my up-to-date progress and the key research objective, and then the motivation of the work, and in the next three sections I'll talk about different reliability aspects of DC collection systems. This is the up-to-date publication list. The paper submitted to the IEEE transactions on power delivery was accepted January this year, and the paper submitted to the IEEE transaction on sustainable energy is under review, and there are altogether 8 publications from my PhD work. We all know that offshore wind energy is a very promising clean energy source, and identification of overall reliability of the system is one of the main tasks performed at the planning phase of an offshore wind farm. Also, at the operational level of the wind farm, reliability is required to consider for optimal preventive maintenance planning. And what is the reliability requirement? When proposing a new concept, reliability is one of the key features that are required to consider on top of its technical feasibility and the associated cost. The main objective of this work is to identify the overall reliability of the DC collection system concept from the component level to the system level. As shown here, there are 4 main areas to consider: the selection of the suitable topology, and the selection of a suitable medium voltage DC converter, which could be 2-level, 3-level NPC or MMC of multi-level converters, and the impact of the cable network in the reliability assessment of the offshore wind power plant, and the reliability of the DC wind turbine concept. In the next section, I'll discuss more in detail of each section. This is the work based on already drafted paper on the reliability and economic evaluation of offshore wind power DC collection systems, which is supposed to submit to the energy special issue. And this flow chart shows the overall methodology used to identify the best topology in terms of reliability and the cost. This in general, for availability criterion, we use the term called generation ratio availability. As you can see from this graph, there are 4 options that we have considered: 3 radial topological options and 1 series parallel topology. We can see that from the availability perspective, radial 1 is suitable over other topologies. In the next work, a reliability and cost-oriented approach is presented to select the optimal multi-level MVDC converter, and this work is based on the published work on IEEE transaction power delivery. And this flowchart shows the overall methodology which have been used. First, it will identify the optimal number of redundant modules from the reliability aspect, and then perform the economic analysis to obtain a suitable topology based on return on investment index. And there are 4 candidate converters has been considered for this topology analysis. The 2-level VSC has been taken as the reference case, and 3-level NPC modular multi-level converter and cascaded 3-level NPC has been taken as candidate options. The analysis has been performed at various currents and medium voltage DC levels, starting from 10 kilovolts to 50 kilovolts, with the current range of 100 amperes to 1 kilo amperes. These results show that with the increase of medium voltage DC level and the currents level, MMC is more suitable topology, whereas at the low MVDC levels and current levels, the 3-level NPC is more economical. The third task looks at the impact of the collection system reliability in availability assessment of offshore wind farms, and this work has been under review at IEEE Transaction on Sustainable Energy. And the main research gap here is to identify the impact of cable network reliability in the overall reliability assessment or the availability assessment of offshore wind power plants. Here the method based on universal generation function is proposed to evaluate this requirement. And to test the methodology, we have selected a real offshore wind farm of 400 megawatt of Anholt wind farm, offshore wind farm in Denmark. The availability graphs shows here that there is a significant error if we don't consider the cable network reliability in the availability assessment of offshore wind power plants, and also the expected energy not supplied for a 20-year period of operational lifetime. If you don't consider the network reliability, and then there could be a significant error in the about $24 million miscalculation of expected energy not supplied, which is a significant figure which needs to consider. And thank you for your attention.